An array. Given an array of integers r, return true if and only if it is a valid mountain array. So what is a valid mountain array? The definition of valid mountain array is here. If the array's length is bigger than or equal to 3, so this is going to be a valid mountain array. The reason is it starts from very small number, index 0, from index 0 to index I, it is in increasing order, and from index I to the end of the array, it's in decreasing order. As you see, it looks like a mountain here, and in this case this is not a valid mountain. The reason is it's increasing order, everything is good here, but then we are going to have a flat line because we have a duplicate number here, and then it's going to be increasing and then decreasing. But because of this flat line here, this is not a valid mountain. So how about this case? This is, it starts from 2 and it's just in decreasing order, so this is not a valid case. How about this one? It's increasing order, but we are going to have a flat line here, so it's not a valid case. How about here? It starts from 0, it's gonna increase, it's gonna be an increasing order, it goes to 3, and then from this point it is in decreasing order, 2 and 1. So this is a valid case. So let's see how we can make this happen. I will give you an example here, a couple of examples, so you can have a better understanding. Let's say we have 0, 1, 3, 2, 0. So this is a valid case. How about this case? 1, 2, 3, or this case? 3, 2, 1. So these are the cases that we need to handle, right? And also we might have a case like this, and then so these are the cases that we are going to have. So this is a valid case, this is not a valid case because it is just in increasing order, this is not a valid case because in decreasing order only, and this is not a valid case because we have these repeated numbers. So let's see how we can do that. We can start iterating from the beginning of the array, and when I say we start iterating from the first index, we are going to use a pointer. Let's say we are using a pointer I, right? So we start iterating over the array and we compare every 2 elements from the beginning. So we are going to compare index 0 and 1, and then 1 and 2, and then 2 and 3, and then 3 and 4, and we are not going to check 4 and 5 because there is no 5, so we should consider this case. So what I'm going to do, because I'm checking every single index with the one beside it, which is at the right side, so it's going to be I plus 1, right? I need to make sure the I plus 1 is within range of the array and it's not bigger than the length of the array. So that's why I'm going to check if I plus 1 it's smaller than the length of the array, and also I should make sure it's in increasing order. So I'm going to say if the array I is smaller than the array I plus 1. This is making sure it is the increasing order, right? And then what I'm going to do, I'm going to increase the I index, and which is I'm going to move the pointer to the right, and we keep iterating over the array. And now we might have this case, which means we have iterated all the way to the end of the array. And so what should we do? We should make sure if the I is in case if the I is equal to the length of the array minus 1, which is the last index, or it might be this case, so it doesn't move forward because 3 is not smaller than this condition is not valid, so it's not gonna iterate forward. So we need to make sure I is not equal to 0, and if it is equal to 0, or if it is equal to the length of the array, we can just return false at this point, and then we are done. And now we should check like we are going to use 2 while loops. One while loop goes from index 0 to the some point in the middle of the array, And another while loop goes from the middle of the array to the end of the array. And in between, we are going to check if I is length is equal to the end of the array, which is going to be this case, or is it going to be equal to 0, which is going to be this case. And if it's either of these cases, so we are going to return false. And now what we're going to do, we are going to check if I plus 1, again, we are going to compare every single item with the one at the right of it. So we are going to check if I plus 1 is smaller than length of the array, so it's not going to be out of range. And also we are going to, now we are going to check in the decreasing order, right? So I'm going to check if I is bigger than the array I plus 1. So we are going to see if 3 is bigger than 2, 2 is bigger than 0, and so on. So what we are going to do, we are going, if this case is valid, we are going to move I one step forward. And after we are done with this, we should be, in case if it is correct, all these things are going correctly, we should have I pointing at the end of the array. So now we are going to have a condition here. We are going to say if I is equal to the length of the array minus 1, which is going to be, it is going to be the last index, right? Which is going to be the last index. If it is length of the array is I minus 1 is equal to I, now we are going, this condition is going to be valid and it's going to return true. Otherwise, it's going to return false, which is going to be this case, because it goes all the way to here. It goes 0, 1, 2, and it goes through this perfectly. And then it checks I is not equal to 0, I is not equal to the length of the array. This is perfect. And then it starts from here. It checks if 2 is bigger than 2, and it's not valid. So this while loop will end. And then we check I is pointing at this place, and it's not end of the array, so it's going to return false. And the time complexity for this is going to be linear because we iterate over the array only once, and the space complexity is constant because we are not using any extra space. And when I run this, as you see, this is going to be a valid case. Our answer is false, and the expected answer is false as well, and that's what we are looking for. Thank you.